Lesson 8-1. Find angle measures in polygons. By the end of today's lesson, we will be able to successfully find angle measures in polygons. 8.1. Polygon interior angles theorem states that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180, where n represents the number of sides. So measure angle 1 plus measure angle 2 plus measure angle 3 and so forth will give you the formula n minus 2 times 180. So for example, if we have a polygon with 6 sides, then if we plug in 6, n for n, subtract 2 times 180, we would get 4 times 180, which equals to 720 degrees. Well, how do we know if this formula will always work? We could count the number of triangles formed. So if I were to cut this convex polygon into triangles, we have 180, 180. Okay, so we have 4 of these. And then times 4, 720 degrees. So if we go to my website, I showed you a proof using inductive reasoning to prove this formula. And there's also a corollary to the polygon's interior angles theorem called interior angles of a quadrilateral, which states that the sum of the measures of the interior angles of a quadrilateral is always 360 degrees. Okay, let's take a look at some examples here. Find the sum of the measures of the interior angles of each convex polygon. So if we just count the number of sides, 1, 2, 3, 4, 5, 6, and then use the formula. So that would be 6 minus 2 times 180, and that will give you 720 degrees. And then for the next picture here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So 10 minus 2 times 180 degrees will give you 1,440 degrees. Okay, example 2, the sum of the measures of the interior angles of a convex polygon is 1,260 degrees. Classify the polygon by the number of sides. So this brings us back to chapter 1. But first, let's calculate the number of sides given the total angle measure. So we have this as a setup, and then we could do n minus 2, 1260 divided by 180 should be 7. So n should be 9. So a polygon with 9 sides is called a nonagon. And part B, the sum of the measures of the interior angles of a convex polygon is 1,620 degrees. Classify the polygon by the number of sides. So we will have to do the same thing. Use the formula, set up an equation, and solve for n. And this would be 9. And then add 2, 11. So we have 11 gone. Okay, let's do example 3. Part A, find the value of x. This happens to be a quadrilateral, so we could just use the corollary. And then x would be, let's see, you have 318 and x would equal to 42. And in part B, find measure angle K and measure angle L. And then how do we go about this? So first of all, we need to find out the total measure. So this is a pentagon. So 5 minus 2, that's 540 degrees. And since measure angle K and L have equal measures, we can do this. If we add 68 to 105 to 109, and I could do plus, and let this be x, and assign my own variables to x equal to 540. And then we can have 2x and equal to 258, and x equals to 129. This would be your answer for measure angle K and measure angle L. Okay, 8.2. Polygon exterior angles theorem states that the sum of the measures of the exterior angles of a convex polygon, one angle at each vertex, is 360 degrees. So no matter what polygon you have, the sum of the measures of the exterior angles is always 360 degrees. So again, I'm going to state it here again. I'm going to give you a quick proof. And in 8.1, we stated that the sum of the interior angles is represented by 180 times the difference of number of sides minus 2. So I can let, here, if we look at the picture here, I'm going to let A1 be one of the interior angles and A2. So then for angle 1, one of the exterior angles could be represented by 180 minus A1, and angle 2 can be represented by 180 minus A2, and so forth. Okay, and if we look at the formula down here, or at the beginning of the proof, the sum of the exterior angles, I'll just put an E here, exterior angles can be represented as 180 minus A1, which I have here, and then plus 180 minus A2, plus so forth. And then let's say we have a certain number of sides, I could just say plus 180 minus AN. And then I could rearrange my terms and say I have 100 n of 180s, and I can move all my A variables to the left hand side and regroup this. So by the distributive property, I can factor out n 180s, and then I could factor out the -1 here and say that A1 plus A2 plus A sub n will represent the sum of the interior angles. So then I can substitute this section with the formula from 8.1, and when I distribute 180 in, and then I would get 180n minus 180n plus 360, and I can cancel this out, and this will be 360 degrees. So here's my proof for 8.2. And on my website, I showed you a slightly different proof, and it still means the same thing. So take a look at both and see what works for you. Example 4, find the value of x in the diagram shown. So I can take 85, 89, x, and 2x, and set it equal to 360 degrees. And then I can simplify. Then x should be 62. Example 5. The base of a lamp is in the shape of a regular 15 gun. Part A, find the measure of each interior angles. Now, before we find the measure of each interior angle, you need to first find the sum of the measures of all the interior angles using the formula from 8.1. So n minus 2 times 180. So we have 15 minus 2. That's 13 times 180 makes 2340 degrees, and since we have 15 sides, we just divide by 15. That gives 156 degrees. And for part B, find the measure of each exterior angle. All you have to do is take 360 degrees, because for any polygon the total measure is 360 degrees, and divide by 15, and that will be 24 degrees. Example 6. A convex pentagon, meaning a 5-sided polygon, has exterior sides with measures 66, 77, 82, and 62. What is the measure of an exterior angle at the 5th vertex? Okay, so first we need to find the sum of all of these. Okay, and then, or we could just take 360 degrees and subtract all of these angle measures, or exterior angle measures. And then we can get 70 degrees. Example 7. Find the measure of each interior angle and exterior angle of a regular nonagon. So the regular nonagon would have 9 sides. Since it's regular, then every angle should have the same measure. So again, by 8.1 formulas, we have to do 9 minus 2 times 180 degrees. So that will give you 7 times 180 degrees, which equals to 1260. And then you take 1260 and divide by 9 to get 140 degrees for the interior. And then for the other one, again, 360 divided by 9. So you can see 40 degrees exterior. So in this video, I've shown you all the basics of using these two formulas from 8.1 theorem and 8.2 theorem. You're expected to be able to solve more challenging questions, and I will look into AMC Online Alchemist Practice. And you can find that under useful links on my website.